Welcome, everybody, to this third episode of the Filtra.io podcast. On today's episode, I was able to have a conversation about a trend that I think is very interesting in the Rust community, and that is Rust being used to accelerate Python. I think I got the perfect guest for this topic. For this episode, I talked to Adrian Garcia Badaracco and Peter Lesty of Pydantic. If you don't know what Pydantic is, you probably don't write Python because their type validation library is a really key piece of the Python community at this point. So I talked to Peter and Adrian about Rust being used to accelerate Python and the Pydantic library, but we also spent a lot of time talking about something new that Pydantic's been doing, which is their Logfire observability platform. Peter and Adrian have been spending a lot of time working on a query engine for this platform, and they talked about how they're using Rust for that project. We also talked about what it's like to work at Pydantic. If you want to work at a cool company like Pydantic, where you can write lots of Rust, I have one recommendation for you, and that is to go over to filtra.io and take a look at the 1,000+ Rust jobs we have listed over there at tons of cool companies like Pydantic. Also, before we head over to the conversation, I have one ask for you. If you're enjoying these conversations, please follow or subscribe to our accounts so that you can get all the updates from us. And with that, let's go to the conversation with Peter and Adrian. So, I use Python a lot. So Pydantic, the open source software, is something that I'm very familiar with. But Pydantic is also a company, and I kind of want to pull apart the fact that it's a company and open source software and kind of help everybody understand this. So maybe let's start with the open source software that started all of this, and help people understand that. So can you guys kind of explain that for people who don't use Python a lot?
Yeah, I think I'll take this one. I've been around the Pydantic Python space for a while. So the Pydantic started as essentially what we call runtime type checking, um, which and this was in a time when Python basically didn't have type checking, or like it had a very nascent, like basic type system. At one point, it was in comments, was Python's original type system. So Pydantic kind of came onto the scene and said, okay, we let you define this class and you can put these newly introduced, like last week, they call them type hints or type annotations on them. And we'll like enforce at runtime that if you say it's an int, it has to be an int that you assign to that field. Otherwise, we'll throw an error. In practice, it ends up being used a lot like Serde in Rust, or Zod in TypeScript or some other libraries like that, where one of the big first use cases was validating essentially untrusted data that you're receiving in a web API or something, right? Like if you receive JSON and you have like an age, and age must be an integer and it's not negative. Instead of writing a bunch of custom checks yourself, you'd add like a type annotation with some metadata to say this is a non-negative integer. And then Pydantic would allow you to like generate a JSON schema from that. And then it really blew up when it got integrated with a web framework called Fast API, which is a very popular Python web framework. It kind of brought async onto the Python web scene. But one of the things it did is you declared your Pydantic models as inputs and outputs of your API, and it would automatically generate like a JSON schema and open API docs and do the validation and stuff like that. So that's how Pydantic started, and it started being written 100% in Python. And then that was slow and accumulated a lot of cruft. So at one point, Samuel, the main original author of Pydantic and founder of Pydantic, the company, decided, hey, I want to kind of rewrite this in Rust. And we started doing a little bit of work with that. I was involved in open source. And then he got kind of at the same time approached by investors who had invested in some open source companies already and were looking for more successful open source projects that were interested in kind of becoming a company. So they approached him. He kind of pulled a team together. I was part of that initial team, and we set out to build a company based on the open source project. And that was very much an open-ended question at first, because it's not like the investors came to us with a mandate of like, for example, I'm going to give you some money and you have to charge users for, your open source library or something like that. It was more like, hey, we think you're, good engineers, you have a good name in the market. You can obviously build products that people like. We're interested to see if you can turn that into a commercial product that people like. So that was the original like kind of investment and what catalyzed it turning into a company. And then from there, yeah, I can kind of go into the story of how we got to where we are now. But that's the relationship between Pydantic, the open source library, and Pydantic, the company.
Okay. That I think that clarifies things pretty well. So, well, I guess when companies are in that position, there's always this leap that you have to make, which you kind of alluded to, which is
Mm-hmm.
like, okay, we have this group of people who are really talented. We have some really great open source software, and now we need to figure out how to build a business out of
Mm-hmm.
this like ecosystem that we have. So, are there services that Pydantic sells around that original open source software? I know there's something else that we're going to dive into a lot in just a minute, but are there services or things that you do around that?
I think not really. We don't charge or sell or anything or do any sort of like consulting or host or anything of the original open source library. We essentially spend our time maintaining it because we think it's a really valuable piece of the ecosystem. But we don't sell or charge for the open source library at all. Essentially the connection between the open source library and the rest of the commercial company is mainly kind of a shared user base. A lot of the users who care about the open source library because they care about, data validation and having a, robust API also care about some of the other products that we sell. Namely, observability is the main product that we now sell commercially.
Yeah. Before we move on to that, just since you mentioned that you were kind of brought in um, when Samuel got that opportunity to start this company, what was the what did that look like for you? How did you actually get involved? Were you working on the open source?
Yeah, I was just kind of, somewhat randomly contributing to Pydantic the open source library, just from using it and finding bugs, and then, as a open source, as a software, any other software engineers involved in open source does, you find some bugs, you find some missing features, you get some ideas, you go and you start making PRs, and so I had some contributions. I was by no means one of the bigger contributors to Pydantic, but I had some, pretty key contributions and ideas that I'd upstreamed into the library.
Okay. Yeah, because I wanted to ask, obviously, the audience for these interviews is a lot of people that like want to find Rust jobs and that kind of thing. And I think a lot of people underestimate making open source contributions as an opportunity to kind of get your name out there
Mm-hmm.
on the radar.
Yeah.
Um, well, okay, so we've alluded to it several times now. Pydantic is working on something kind of big, new, exciting right now. You've got an observability product called Logfire,
Mm-hmm.
and I think we want to spend a lot of time digging into that and how that's uh, shaping up. So, um, I kind of ended up doing a lot of research yesterday on this, but people who are listening will be coming in cold. So, kind of give us the groundwork of like why Logfire needs to exist. How does it differ from the existing observability products?
Mm-hmm. Yeah. So I mean, so basically, when we had to build a commercial company, we sat down and we thought about what what can we sell. We know we don't want to just sell our library or license it or something. Um, but what can we sell to kind of the same users or the people who care about the same things? And the logic went something. It was a mix of what products do we think there's no good version of out there that we love, and for our users specifically, like I said, Pydantic was used a lot in data validation and like in web frameworks and the same kind of people who care about, the data coming to the web frameworks being valid, care about, performance, correctness, that sort of thing. Um, Once you deploy your application, if you're just getting errors because you're being sent invalid data, or you're creating invalid data, you're pulling invalid data out of your database and stuff like that, and aren't able to return to your users, where does that go? You need some sort of observability. Like Pydantic helps you catch errors almost at like, it's not like compile time, it's like, run time maybe in your tests. But once you've deployed your application, there's all sorts of new errors that might be showing up, and that's where observability helps you catch those.
That's actually, I like how you made that connection along the lines of correctness, because I feel like it's like you've got sort of like compile time correctness. You guys use a lot of Rust. Obviously, that's huge selling point for Rust. Kind of runtime correctness, Pydantic, and then I guess also runtime correctness, but sort of in production correctness with
Yeah.
Logfire.
Once like all the wild things that happen when you scale and have users and whatnot, start your downstream service times out, your upstream service times out, your, all kinds of things go crazy. And then you need another level of being able to know what's going on. One of the things that made Pydantic very popular was like the errors that the library returns. Like a lot of, if you try and like parse some invalid JSON with like the Python's built in like JSON.loads or something, you'll get like some obtuse error about like expected some bracket but got some whatever, and it's not clear why it didn't parse. Or if you write some spaghetti recursive code to parse yourself, you get some huge traceback that makes no sense. But Pydantic did from the beginning a very good job of saying like, this nested field, the fifth item in the list was expected to be this struct that had this field that, like it gives you like the whole like chain of essentially where the thing went wrong. And I'll tell you, hey, I expect this to be an integer, but I got this string, and like both things will be in the error message. So it's like when you get an error, you can tell what happened. And that's one of the things that like annoyed us about a lot of existing observability. Like if you think of, the old school, like I have a bunch of log lines and I'm trying to figure out what happened. You don't have that context. You're again kind of looking at that like isolated error in one place. Like expected an integer, got a string, couldn't parse it. And you're like, but where? I sent, a 1 MB JSON blob. Where in this JSON blob is the issue? Similar thing. I have like a million log lines. I have errors all over the place, but like what called what in those errors and stuff like that. And so one of the things we wanted was to build an observability product that was uh, based on tracing. And in the tracing world, what we have now is an industry standard open telemetry, and that's kind of what the fancy Pydantic errors are for parsing JSON. They're that for observability. Instead of looking at like isolated things, you get context of where your errors happen, what was slow, that sort of thing.
Could you guys actually explain a little bit more the open telemetry piece? Like what does that look like really concretely?
Yeah, Peter, you're pretty familiar with it. Do you want to take that one?
Yeah, no worries. So like, OpenTelemetry is like, I guess, a standards platform. Um, there are, I think there are libraries for pretty much every major language under the sun, including Go, Rust, Python, all that sort of stuff there. And so what it does is it provides an interface for people that want to perform tracing and want to be able to send those traces to some sort of API somewhere to collect the data, whether that's Logfire or another system. And so it provides not only a way of sort of instrumenting or like decorating your code so you can actually work out what's going on and then put like little trace and span bits where you want them to, but it also has some, I guess, RESTful or gRPC style like APIs that are standard as well, which means that anything using OpenTelemetry can talk to anything else. There's a couple of open source collectors and things like that that people can use, and but yeah, pretty much OpenTelemetry is a good standard way of collecting tracing data. When you deploy an application, sometimes you're not always writing it in the same language, sometimes you're not even using the same product. You're going to be like a polyglot. It's just common now that you have like things talking different languages. So having a standard platform to connect that all together and see from like in the context of a web, like the beginning of a request, even from the browser, all the way through to the end and the back end, and having that sort of unified, it's excellent for that. And they're good building blocks to build other things on top of. So it's a really good, strong foundation for the tracing design.
So, when we were preparing for for this interview, we were talking about some things that we might talk about, and one of the things that you guys brought up was that one of your big projects right now is building a query engine within Logfire. You mentioned that that's like a lot of your, time writing Rust is on this project, and so I wanted to talk more about that. And one of the things that you guys had mentioned is that you're basing it on data fusion. Um, and went and looked into data fusion, thought that was really interesting. So maybe could you guys explain data fusion before we talk about the whole of the engine?
Yeah, sure. Um, Data Fusion is basically an open source. I don't know what would you call it, Peter. Like, it's not a query engine; it's like query library, or it's like a Lego.
Like build your own database and have the toolkit to do
Yeah,
basically create a new database.
yeah. It's like a Lego toy, where you get the Lego toy, and it comes with some instructions to build a dinosaur. But then like you can like go online and find instructions on how to build a car as well with like most of the same parts, or like a house, or like different things like that. So it's like there is like, and I say that because there's like a CLI kind of like DuckDB, or and there's a library like a Python library like Pandas almost that you can use to do like just out of the box querying of Parquet files, CSV files, that sort of thing. But what most people actually use it for is like to take pieces of that. Some people use the SQL parser. Some people use the computation part, but not the data scanning part. Some people use only the data scanning part. So there's all kinds of like mix and match and build your own database that people do with Data Fusion. Andrew Lamb, the main maintainer, likes to call it the LLVM of databases, which is an interesting take. But yeah, it's just basically a toolbox.
Yeah, that makes sense. Andrew Lamb, notable Rust programmer as well, I think, right? Um, yeah, it was interesting to me to learn about that and how like it did make a lot of sense to me what I read about how there's all this work now going on of like everybody's building a new database or rebuilding this or that database. And the point was kind of you don't need to rebuild every single component of a database because there's a lot that goes into that.
Hmm.
And so like why not have this stuff that we can share and then people can focus on
Yeah.
the parts that make what they're doing unique. Um so well actually so how does that fit into what you guys are doing building a query engine then? Like what pieces are you reusing? What are you building? What does that all look like?
So I guess what are we using Data Fusion for? Well, it's really like what we're using for Logfire to store and query information. So anytime like an open telemetry trace comes in, that needs to be stored somewhere. And then when we want to present that information to a user, we want to be able to query it. So we're using it quite extensively in the Logfire backend. Um, the main components that obviously we're actually using quite a bit. So we're using like the query parser, we're using like the physical scan component, we're using the query like planning engine as well. We've added our own bits and pieces to decorate that. Like there's a bit of so for instance, one of the things, and I guess we can talk about this later, is we have our own caching layer on top of what Data Fusion offers, just to speed up like talking to cloud storage and things like that. So the ability of the good thing about Data Fusion is you can sort of pull it apart and just inject your own bits that you want to increase performance. But essentially, we're using Data Fusion quite extensively um, from the onset of like when a query comes in, like an SQL query comes in, to like actually getting those results and sending it back to the client. So yeah.
Something that just occurred to me, and maybe I'll sound a little dumb asking this question, but I don't mind that.
Yep.
So I imagine data fusion and like query engines that, in my mind, that has like a relational notion to it. But is the data that you're storing inherently relational, or is there kind of a mapping that goes on there?
Yeah. So it is relational. Essentially, we store metrics and traces as tables. Um, it's kind of a denormalized table, which ends up it's pretty common in analytical systems to like denormalize because it makes it easier to manage large volumes of data. So there's like essentially what you'd call like the non-relational part where there's, for example, a Kubernetes pod is an entity that exists, but we don't have like a Kubernetes pod table, right? And then like a bunch of references back and forth to it. We just, in every row, we copy the Kubernetes pod name, the Kubernetes pod IP, Kubernetes pod name, Kubernetes pod ID, if it applies to that row, because not everything is a Kubernetes pod. But if that log message or that trace came from a Kubernetes pod and information is there, it's just copied into every row. Um, and because we store things as Parquet, and that gives you dictionary encodings and other sorts of compression, ends up being not that bad. If you have, if you have the same Kubernetes pod name and, a million rows, you might only store it, maybe 100 times. But what that lets you do is you don't have to worry about like keeping foreign reference integrity and any of that kind of stuff.
That makes sense. So Rust apparently plays a big role in this project. So how does it fit in to, what you guys are building?
Well, Data Fusion itself is written in Rust. Our query backend is written in Rust, as well as a few other components. And yeah, that's pretty much like, I guess, where the Rust play comes in. So there is a strong component of Logfire that like is in Python and backend, and a lot of the, I guess, administerial things like managing users, organizations, that sort of thing. But definitely the query engine, and I guess the part that needs to be extremely performant, we've written in Rust. And we have oxidized a couple of other bits and pieces since I've been here, and moved on to use Rust in areas where it makes sense. But obviously, for like, I guess, development velocity, it doesn't make sense to use Rust everywhere, but definitely where performance matters, it's something that we have a focus on.
I feel like there's like a divide in the Rust community of those who believe that Rust needs to be everywhere versus those that are like, no, it's good for these certain things and we should use it for that. I'm definitely on the more pragmatic side, but
Yeah, it'd be nice to use that in everything. Like, it'd be great. Like, I'd prefer it to use in everything because I've got more of a Rust opinion on things. But realistically, there's a lot of there's a whole ecosystem in like even Python and even JavaScript that like there are so many great libraries out there that it just does not make sense to rewrite it in Rust, because you're going to be rewriting millions of lines of code to get the same functionality out. And so it makes sense to use Rust where there is like a good purpose for it. But I think you do need to be pragmatic. It's not something that you can use absolutely everywhere. And especially, yeah, in a system like this, like we wouldn't have the velocity if the whole thing was written in Rust from ground up.
Yeah, I mean, not to mention compile velocity
Mm.
would be quite slow.
Yeah.
Uh, um, yeah, no, I mean, I think the other thing to keep in mind is hiring, which is another reason we don't write everything in Rust. Like, it's very easy to hire someone who knows how to do React, someone who knows how to do insert Rust WASM based front end or whatever. a lot harder. Or even just backend, just hiring someone who's familiar with the Rust web frameworks and stuff is a lot harder than hiring someone who's done Django, Fast API, Python frameworks, that sort of thing.
Yeah, that makes sense. Are you guys pretty much a Python shop outside of Rust?
Um, yeah, I mean, I feel like in terms of lines of code or something like that, we're probably split like a third TypeScript, which is everything front end related, a third Python, which is a lot of like are just like more day-to-day backend or less not performance critical backend bits, just user management, like create an account, that sort of thing. Um, and then about a third is Rust.
Makes sense. So, in terms of the query engine project, I always like to ask people, and the reason I ask this question is, again, coming from that angle of sort of hiring and like, I like to show companies that hire Rust engineers and that kind of thing. I like to give people a flavor of the type of work that goes on at these companies. So I wanted to ask, like, what are the more interesting challenges you guys have run into while working on this?
We've run into so many challenges. I can't even I don't even know where to start. I mean, I think like
It seems like you guys have some scars here.
I
oh
was
yeah,
Scars is probably not the right word, but there's definitely like we've definitely run into some hairy problems along the line. Um,
yeah.
like for instance, one of the things that like I find is a bit frustrating in Rust is like, yeah, you don't have garbage collection, and it's all sort of managed magically for you. But then what do you do when things start going out of memory? And how do you actually, profile a Rust application and look at the heap and work out what's chewing up memory? We ran into that like many times, where, we've just, it may be like, sometimes it's a mistake that I've made. Sometimes it's like an external library just chewing up data, or sometimes we've got a struct and we've got an instance of this struct which is mostly empty, but there's like 10 million of them for whatever reason, and then that's chewing up memory. So it's like, for me, like a big strong one, and is something that probably needs a lot more care from the Rust angle, is like memory management. It's kind of a strange thing to think about, because it's like, well, but Rust, you don't need to worry about memory, but you sort of do as well, and need to look at it even more.
Yeah, I think we've also run into just a lot of issues that just stuff like HTTP connection timeouts being out of sync.
Mm.
They're like so annoying because like every now and then you get a blip of errors from some system, and you're like, why? When does that happen? And you're like, it's like trying to look for Schrodinger's cat or something. You go in there and you look, and everything looks fine, and then you walk away, and you come back the next morning, and there was like a blip of errors at 3 a.m., and you're like, why? And it's like your keep alives are a bit off, and so you're keeping a connection open to something that's the server's dropping it, but you're keeping it open, and you have to go and tune those numbers to like sync them up, and a bunch of fiddly stuff like that is just like constantly pops up left and right where you least expect it, and is like honestly not even like a Rust thing. It's just building a data intensive high scale system sort of problem.
Yeah, it sounds like, I mean, just from what each of you said, I mean, this project is the core problems you're solving are what you kind of would expect. You need a certain level of performance, and you're kind of rubbing up against the edge of what's possible, and so you're going to run into those type of problems. That's very interesting. Um,
Yeah, I think it's just the kind of it's if you're running an application that just makes a database request every now and then, and does light work, let's call it, then you're not going to run into issues. But if you're like constantly hammering GCS, your database, your ingestion systems receiving millions of requests a second, then like any sort of like small issue can become a big issue, and in some cases even like snowball into like just like getting worse and worse, and like requiring a lot of immediate attention.
yeah. I guess I didn't ask. Is this query engine in production right now, or is this something you're working on? Like, where in development is this right
It's
now?
in production. Yeah.
Yep.
So we have two main instances. We've got one in Europe and one in the US. The US is probably the main one. And we also have self-hosting option as well. So it's in production. And so it's like, not only do we have to worry about like the cloud environments, we've also got to worry about on-prem, which is just because you've got to like do everything with like big thick gloves on when you're doing on-prem stuff, like just like trying your best to work through that and work through, I guess, some of the integration challenges you have there. But yeah, it's been running. I don't know how long has Logfire been up and like an actual product, Adrian?
Trying to think. I feel like we had our first like commercial paying customers maybe like a year ago now,
Okay.
maybe a bit more, a year and a half, something like that. Which is eternity in startup time. It feels like forever. I don't remember a time before that.
Yeah, that's funny. Well, I guess I'm also realizing I don't know, is Logfire, are any components of it open source, or how does that work with that product?
Yeah, so we have SDKs, and those SDKs are completely open source. So essentially, like any code of ours that you run is completely open source. Um, but the rest of it, like the actual platform itself, is closed source because we, are a commercial company that wants to make money. And so we want to be able to charge people for that. We have a lot of open source work we do in Pydantic library itself and Data Fusion. Like we aggressively contribute whatever makes sense open source, but we don't just release our entire product out there and be like, hey, run it yourself for free. It's not a good experience. It's not good for us as a company, at least not right now. Like financially, in terms of like being able to know what customers to focus on, in terms of like balancing concerns, right? You get like 1,000 different people opening issues for things that are broken, and it just makes it hard to filter out the noise. And that sort of thing. And it wouldn't be a good experience for customers because it's a complex system to run, and they'd be spending so much time just doing that and getting frustrated and things being broken that it's just not. It wouldn't work for anyone, at least not at this stage. We've talked about maybe open sourcing some things in the future,
Yeah.
but I think that'll only happen once the product is less in flux and the company's more established.
You can use the Logfire SDK to talk to other open telemetry stuff as well if you really want. You can, it's to instrument it, but I think it works a lot better talking to our backend.
I'm sure.
Mm.
So, um, one of the reasons I was excited to talk to you guys is because of this theme that I've kind of been tracking of well, what I'm calling Rust accelerated Python, basically. And that's kind of how I have been putting together these interviews lately, is like I have these themes that I think are important in the Rust community, and I'm trying to like pull in the voices that I think are a part of that. Um, so yeah, I wanted to ask you guys about this, because I think you have maybe a little bit of a privileged position. Obviously, the Rust accelerated Python thing is very real in the case of Pydantic. Um, what observations do you guys have about this trend?
Yeah, like you said, it is becoming very popular. I mean, that's what Pydantic, the open source library, is right now. It's ultimately a Python library, but it's accelerated and backed by a bunch of Rust. All of the performance sensitive stuff happens in Rust, and we have a JSON parser written in Rust and all that kind of stuff. And you see it also like related company like Polars, the data frame library. They're all written in Rust, and they're related because they exist in the same query engine space as Data Fusion does. Um, and to Peter's earlier point about what you write in Rust and what you write in Python and stuff. Yeah, to some extent, like Python is a glue language, right? That's what it's historically been used for. And it turns out Rust is an excellent. If you're going to build libraries that are widely distributed, right? Like it's worth investing the time up front to build it with a language like Rust that forces you to some extent to build things more efficiently and reliably. And because there's really good interop between Python and Rust via PyO3, which is actually maintained by David Hewitt, who works with us. It's like the DX as a developer of writing a Rust extension and wrapping it and publishing it is really, really good. Better at this point than it is, I think, for any other sort of Python extension language. So yeah, I think that's where a lot of it comes from.
That's a big deal that you just said, that the developer experience is better than any other Python extension language. I don't know that I've heard that before, um, but I feel like that alone could really drive the trend.
Yeah, I mean, look, I haven't developed anything in Python in a long time, so I take it with a grain of salt. But like the Rust ecosystem in general is known for being very strong, right? Like the LSPs are good. The package manager Cargo is very good. It obviously has its flaws, but like on the all, it's like one of the better languages out there in terms of like developer experience and ecosystem. Um, and then the packaging of the interop has been done very well. I think it's like quite smooth for what it is. Like there's templates out there. It's like you can very easily just like build up and publish and get going with like even the CI part of it, like a package that's Rust under the hood and exposes a Python API.
Yeah. You mentioned David Hewitt, and I should shout him out because he was the one who told me that I needed to talk to you guys, and I've kind of been bouncing these ideas about Rust and Python off of him, like who should I talk to? Um, so yeah, I mean, PyO3 is a huge, um, I don't know, benefit to this ecosystem, for lack of a better way to say it.
If you've ever tried just writing like Rust libraries for other languages, it's an uphill battle. I've written a few libraries for like C#. You can do it, but you've got to like wrap things in FFI. You need to worry about sort of unsafe code in Rust that you can't guarantee. You need to make sure marshalling happens between them. Like it's a lot of effort, and a lot of that is like abstracted away in the most like zero cost form you can do with PyO3. So like it is a great dev experience that we have a library like that it seems to integrate very nicely. And definitely before I started with Pydantic, I was using PyO3 in my old job to wrap a lot of Rust libraries in for Python. And it's actually quite a boon to productivity that you can do that and do that in an easy way.
Yeah, I think it's a big deal. Do you guys feel like and it almost feels like you've answered this question already, but do you feel like there are any blockers that would kind of keep this Rust and Python trend from accelerating?
Yeah, I mean, it's that there's difficult things like the one that comes to mind just because I was talking with David and some other people brought it up not that long ago, which like I think is going to be solved eventually, but it's like a really, really hard engineering challenge. It's going to take years. Is um, essentially sharing data between two different Rust Python extensions, or sharing data or sharing behavior. Really, sharing data is kind of solvable, right? You like serialize it to something, protobuf, JSON, whatever, Python, and then deserialize on the other side. Like that may be a bit expensive, but it's doable. But what's currently not doable is like I can't write, for example, a custom Rust function. Like I can't write a function in Rust and then hand it over to say Polars. Well, actually, sorry, Polars does do that. I forget how they do it. It's some like magic way, but like in general, that's not possible. Like Data Fusion CLI doesn't allow you to write it's written in Rust, or the Data Fusion Python API is written in Rust under the hood, but you can't write like some Rust function and pass it in. You have to like essentially wrap your Rust function in Python and pass that in as a Python function, and it might still be efficient enough, but like you're ultimately going from like Rust to Python to Python to Rust or something like that.
Yeah, definitely like the ABI story in Rust would be needs a bit of work. At the moment, everything's, has to use the C ABI to interface with this stuff, and we're limited by that. And I think that would be like the biggest blocker is, yeah, like, but even not even related to Python and Rust, like having Rust with like dynamic libraries is a pain at the moment and things like that. So, and then that sort of falls forward to like embedding in other languages. And so I think the ABI story, I don't think it's a huge blocker, but it is something that does cause a little bit of friction, especially when there's so much more you can do in Rust that you just can't really like, you sort of, at that barrier, that interface, you've got to like get rid of a lot of the stuff that makes Rust fun and productive, and then go to like normal data structs and things like that, and then send that through.
That makes sense. So let's change gears a little bit because I do want to ask about Pydantic as a company. So kind of coming out from the technical stuff that we've been in. So tell me about the team. Is there anything about kind of the team that you guys have that makes it feel like this group is particularly well suited to taking on the problems you're dealing with?
Um, I mean, I think we have a very strong team in general. I mean, Peter's one of the best Rust engineers. I have to say one of the best only because I've worked with David Hewitt, who is, also such an amazing engineer. Uh, that yeah, we have like some really great engineers. We have a really good mix of people with experience in, distributed systems and deep bits of, like I know if I hit like some like issue with, almost like compiler level issue or stuff like that, I can go to David Hewitt and he's gonna be like, oh, this is some like arcane, thing inside because he's been in all those bits. We have some great DevOps people who have like taken like I built a lot of the original infrastructure that we had, and they've taken that and made it 10 times more reliable and scalable, and all these and worried about all these things like topology, distributing your nodes across multiple zones and stuff that like are I may know exist but are way beyond my ability to just like whip up real quick. Um, so we have a really good mix of teams, and we have a really strong presence in the open source world. We are some of the biggest contributors to Data Fusion, and that gives a really nice collaboration with a lot of other teams at big companies that are using Data Fusion, as well as just the community as a whole.
So one of the things that I started thinking about when we hopped on the call and Peter was telling me that he's in Australia is you guys have people in the US, in Europe, in Australia. How does that work look? Like, are you using open source kind of style work to, work together, or are you finding ways to, get on calls a lot? How are you synchronizing?
What do you think, Peter? How does it work from your end?
Yeah, well, like, to be honest, because we have, I guess, a bit of an open source bent initially, like a lot of the processes that we have in place for open source, like pull requests and things like that, which is standard at any company, but I think more so here, has come across, and we actually use that pretty well. In terms of synchronization, there's a couple of things that I think is quite helpful. A few times a year, we will meet up in person and spend a week just writing our ideas and working through that. I think that's quite helpful, especially when you have a distributed team. I don't think there's anything like anything that we deal with that's like not dealt with other remote teams, though. I think though that we do, because we have that sort of open source base, that a lot of the people that join the company or get hired, they can sort of hit the ground running, and it's something that you know they're used to that workflow anyway, and it's just an adaptation of that, and something that is quite comes natural to most people that join the company.
Yeah.
Is there anything else? Well, yeah, is there anything unique about kind of the culture, the way the company works that you think is worth mentioning?
I mean, I think that yeah, the thing we are just talking about, kind of the open source culture, is a really important part of how we do things. Like we we don't like I think, like some companies may think of their code base as, this thing that's private to the company, and that although our internal code base is not open source, we think of our code base as like the whole range of, our internal code and our dependencies and stuff. And we are, I'd say, pretty much constantly, finding bugs or missing features or, whatever, and in like our dependencies. And, we'll go and we'll try and upstream that. Like people make, it's not like you bring up in the meeting, hey, I found this, I think I'm going to open a PR on this library and stuff. Like you probably just open the PR and don't even tell anyone, and it gets merged like 2 weeks later. And, then you make a PR to update the dependency or whatever, and that's all like resolved. Um, I think, yeah, that's a really big part of our culture.
It maybe seems small, but I think that that's kind of a big deal. Um, I just think a lot of engineers actually really care about that. They care about open source. They care about, you know, upstreaming things and sort of being a good member of the community. So I think a lot of people will like to hear that. Um, from a pure like hiring perspective, uh, I'm sure you guys have kind of seen people come and go a little bit. What are the things that tend to make new people really successful at Pydantic?
Um, I think being sort of like self starters, or being able to navigate work on their own because of, the time zones and the open source type culture. We don't have a lot of meetings. Um, we also don't have a lot of, like we don't have like product managers, saying like, hey, you need to build a button here and this thing here and whatnot. I think there's a lot of freedom, but, sort of like Spider-Man style, with great freedom comes great responsibility. It's like you can go and you can make your own PRs and stuff, and like, if you disappear for a couple days and are working on some upstream thing, that's totally allowed and encouraged. But then if, that ends up needing to provide value and benefit to the product and the company. um and so yeah, so I think it's being able to kind of operate in this world where, like, we're geographically distributed. We're a pretty flat organization. So you're not gonna have like anyone holding your hand on what to do. We're a startup. There's a lot of times not a clear path into like what's the feature that needs to be implemented, or what's the product change that's needed. It's you you somewhat have to be an engineer. You also have to be product. You also have to be a user. You also have to be like a support engineer. You need to be able to, if you made a feature, you need to be able to help customers with that feature and understand how they're going to use it, and follow up requests and all those sorts of things.
Anything you would add to that, Peter?
Yeah, I sort of agree as well. It to like when I first started, it was definitely a lot of like getting used to the product, getting used to data fusion. But data fusion itself is like a big project, like a massive project, and so you need to be able to, I guess, be a bit self-reliant, more self-reliant than you would be at another company, and be able to be productive in your with your own means. It is like it's just the nature of like how we're working these days that you do need to have some, like, you need to be able to unstick or unblock yourself. Like there are occasions where, like, maybe like I've gotten up to a point in like a PR that I'm writing, like I've got no idea, let's think about it. But then you don't just sit there twiddling your thumbs, you go and find something else to do. It's not like there's a lot of work to be done, and especially in a sort of startup culture, you do need to wear many hats. And sometimes you've got to dip into other bits of code that you're not familiar with. Sometimes you've got to write in languages that you're not familiar with. Like I've written a bit more Python in this job than I have in the last one. And that's something that, like I would say is just, something that as a new starter, you would want to think about, like how are you at being, I guess, self-reliant, as opposed to having someone telling you what to do most of the time, because a lot of the time you're going to be left to your own devices, and you're going to have to find that productivity yourself, rather than have someone drive you and like, sit next to you and talk to you and micromanage you. Because I mean, no one really likes that anyway. So it's a good culture to have. But back to the Spider-Man thing. With great freedom comes great responsibility.
Um, well, cool. So I guess the last question that I had in mind was kind of about the future of the company. I mean, you guys have mentioned that it's a new startup several times. Adrian says he can't remember past the last 18 months. Um, what are you guys excited about in the future? What do you see coming that gets you excited?
Yeah, yeah, it's interesting. I think, it's when you're in the day to day, sometimes it can feel like, we're so far away from the goal, or okay, maybe we haven't hit in like, you know, hockey puck. Like I think we might be an older company than like, I don't know, Cursor or something. And they've definitely grown a lot more than we have in the past couple of years. But at the same time, we started a commercial product a year and a half ago and we had no customers, right? And now we have like more customers than I can count, right? At one point there was like the 5 key customers I could keep track of, and now there's just I can't anymore. Um, so I think continuing to grow is going to be a really interesting, really challenging, and really interesting. It's going to be a mix of both technical and organizational challenges. I mean, we're like 20 people right now. There's things we could do with 5 people that we can't do anymore with 20, and there's things we can do with 20 that we're not going to be able to do anymore with like 50, right? It's like 20 people, I know who everyone is. Once we get to 50, it's like, do you even know everyone who works at the company anymore? Um, so yeah, it's going to be a lot of change and a lot of figuring out. I've never been at this stage of startup before personally. So it's I think new to me, new to a lot of us. Um, and you figuring it out is going to be a really interesting journey.
What would you say, Peter?
Yeah, I'd sort of empathize with that as well. We've built a product. We're at a point, sort of an inflection point now, where we have like quite a good solid base. There's a few things that obviously we want to do in the database query team that we want to do, which is like optimize the heck out of it and make it run really fast and like just be a really good developer experience. And I guess that's where our focus is. It's going to be exciting to see where the product is in a year's time, because we have like it's sort of seeing the forest through the trees. You're in the weeds quite a lot, and it's like it's very hard to reflect on that where it is because you've been so involved in it. But if we look back about like where I started like a year ago, like it's really like improved quite dramatically. If we can keep this velocity and we can keep, adding extra features and stuff like that, then I think it's going to be a great product in years, even greater product in a year's time. Definitely,
Yeah.
I mean, like, I feel like I'm one of the biggest users of the product because I use it to like, like, I'm using it to actually like troubleshoot itself. So it's sort of the snake eating the tail there. So it's kind of weird, but that just goes towards our culture, which is like we dog food a lot of the stuff that we do as well. But yeah,
Yeah.
I mean,
Yeah, we are a main observability platform. Um, yeah, I mean, one of the things that I find fascinating was we had a conversation not a couple weeks, a couple months ago. I think I forget what we were looking at. I think we were looking at like maybe like cloud spend or something, and just like
yeah,
trying to bring it under control or something. And we are like, it's like doubled in the past, like, I don't know, 6 months or something, or 3 months or whatever. And we're like, that can't be good. And then we looked at our usage, and our usage, had like gone up like orders of magnitude. And we're like, oh, okay. So we've been doing a lot of good. Like if we hadn't been doing all the work we've been doing, uh, you know, everything would be falling over, nothing would work, everything would cost 1,000 times more than it does.
yeah,
So that's one of the interesting things about, being at a startup and kind of growing your product is yeah, if you look at the just now, you can be like, or you look at just some of the data, you can be like, oh, this is difficult. This is there's so much work to be done. But then you take a step back and you look at where you were 6 months ago and where you are now, and you've done a lot, and it's cool to see that, and it's exciting to see us continue to do that.
Yeah. Well, I'm super excited to follow along with your guys' growth. Now that I know you guys and have talked, had this conversation stuff, I'll be even more invested. Is there anything else you guys wish we had the chance to discuss before we finish up?
No, I think it's been a great chat.
No, nothing
All
from me.
right. Well, thank you guys.
Yeah, thank you. Bye bye.